This is the AWS News Desk, live from Seattle, with your host, Rudy Chetty.
Machine learning dominated the news today at the AWS reInvent conference. In fact, the company held its first dedicated machine learning keynote. In all, 10 announcements today, adding to the 10 we heard about last week. Today's show is going to take you through all the top highlights, so let's get started.
Machine learning is one of the most disruptive technologies we will encounter in our generation.
AWS VP Swami Sivasubramanian noted that since the first AI services launched for AWS in 2016, his team has released more than 775 significant features and services.
As you can see, we are building the most comprehensive set of machine learning products because giving our customers the right tools to invent with machine learning is necessary to unlock the power of this technology.
Amazon Sagemaker is one of the fastest growing services in AWS history, with tens of thousands of customers using it around the world. It now has 9 new capabilities. There is Data Wrangler, which reduces the time it takes to prepare data for models from weeks to minutes. And Feature Store, which creates a repository that makes it easy to store and share machine learning features. According to Swami, features are the foundation of high-quality models.
Your model's predictions are only as good as the data and features that uses. That's also why we need to better understand the bias in the data our models use and why our models make a certain prediction.
Sagemaker Clarify, another new launch, is helping to mitigate bias in models. We'll check in with one of the scientists behind this important launch in a minute. Today's launches aim to simplify the life of data scientists and developers. A new capability for Debugger lets customers identify and reduce training errors and performance bottlenecks before they hit production. This is launched alongside Sagemaker Pipelines that addresses another common frustration in machine learning, creating ML workflows that are repeatable and scalable.
With just a few clicks in Sagemaker Pipelines, you can create an automated ML workflow that reduces months of coding to just a few hours. Sagemaker Pipelines takes care of the heavy lifting involved with managing dependencies and tracking each step of the workflow.
In all, the keynote was packed with many more launches than we could possibly cover in our short program. But just ahead, we're going to dive into how developers can detect bias in AI, talk about industrial machine learning, plus hear about another launch from today's keynote, Amazon HealthLake. One of the big announcements today is the launch of Amazon SageMaker Clarify, a new service that is making it easier for data scientists and developers to understand why machine learning models arrive at their predictions. I'm joined now from Atlanta by Dr. Nashley Cephas, who is one of the scientists at AWS who leads the algorithmic bias and accuracy work. Thanks for joining us, Nashley.
Thanks so much for having me.
You have a different role than most. Tell us a bit about the work you do and why you are passionate about it.
As a Black female scientist in machine learning and AI, I'm both a user of the technology as well as a developer of the technology. And so I'm very passionate about the topic of fairness and biases in AI and machine learning. And so whatever the team and I can do to help towards these efforts, we're really excited to help provide real-world solutions to help mitigate these issues.
Can you give me a real-world example of where bias may creep into a model?
Right. So if you take a TV recommendation system, and it's only been trained on TV dramas, but let's say you're a user who likes TV comedies, then that model will be very much so biased in recommending you those dramas. And so this is the sort of data bias that can be identified up front with SageMaker Clarify.
So why has this been so hard to do prior to this?
So it's been pretty difficult because there really isn't a core standard for this type of work. Most of the time you have to piece together several pieces of code or open source languages or libraries, and it's really left up to the user. And so if we can provide if we can provide an easy interface that allows people to create this standard and allows them to integrate this into what they're already using. For example, Sagemaker, the other Sagemaker tools, then it makes it a lot easier for the person to reassure themselves that they're on the right track on mitigating biases.
Great news today for more than 100,000 customers running machine learning on AWS. Thanks for your time, Nashley.
Thank you so much.
That was Dr. Nashley Cephas, Manager of Applied Science at AWS. The industry is abuzz with all the developments in industrial machine learning from AWS. In all, 5 new services with a variety of sensors and computer vision capabilities were announced. AWS VP of Machine Learning, Dr. Matt Wood, explains how they all work by taking the idea of a pencil in a production line.
Like many industrial processes, pencil manufacturing is a high-volume, low-margin game, which is automated in part, but still requires several manual steps to keep moving. So let's look at our pencil manufacturing line. Large compressors create the pencil wafers, and large-scale, high-throughput machines insert graphite, paint, and then sharpen the pencils. Industrial machines like these include dozens of individual sensors. Using Amazon Lookout for Equipment, the sensor data from this equipment is aggregated and analyzed using machine learning models, which are trained using your own data, but require no machine learning experience to apply. The ML models are trained to identify early warning signs of future operational issues by monitoring behavior such as how many reps per minute is considered normal for a machine. These are the proverbial needle in the haystack problems that, if found early, could help avoid expensive downtime. When the ML model detects a potential issue, such as a sudden drop in the rate of repetitions of this pencil wafer machine, the service will send text alerts so that you can send engineers to take a look or preemptively inspect the equipment for issues way before disaster strikes and the entire line is impacted and has to come down. Even with this sensor data, in lines like this, there is often bound to be blind spots. Equipment which either doesn't have sensors installed, or rotating equipment such as conveyor belts which move products between equipment and provide a potential point of failure. Monitron allows you to completely remove these blind spots by expanding the coverage of the sensors with an end-to-end machine monitoring solution. Process engineers can install Monitron sensors onto machines to start closing these blind spots in minutes. Like on this pencil sharpening machine, once the sensors are installed, you can start collecting data such as vibration and temperature, which is then analyzed automatically. And any early warning signals that deviates from the norm are flagged to staff on site through a mobile app, providing a completely closed loop for monitoring and remediation, which requires no machine learning or even AWS skills to set up and operate. Now, quality at every step is critical in lines like this. Even small imperfections at each step can compound, and they get more expensive to correct as they move down the line. Amazon Lookout for Vision uses machine learning to automatically evaluate quality at every step on the line. Using as few as 30 reference images, Lookout for Vision can identify even subtle defects, such as misalignments, dents, and scratches, sending alerts and notifications as soon as defects are identified before they move down the line and impact entire batches of products. Amazon Lookout for Vision processes the pencil's images from the cameras along the belt, and the model analyzes them for defects in real time. Each time it spots a lead that is out of alignment, it will record it and report the rate of defects via an online dashboard so that you can take action such as maintenance or the switching off of a line to stop more defects from occurring quickly. Now, of course, these lines don't exist in isolation. They are surrounded by entire teams of people, stacks of inventory, other lines, and dozens of other pieces of equipment and moving vehicles. In addition to monitoring each process, many customers have installed cameras to help monitor the environment as a whole. With the AWS Panorama appliance, these cameras just got a whole lot more useful. Now you can process video on site with low latency. So, for example, you can count and monitor inventory and analyze its movement through the site, or monitor the impact of process changes for improvements. Panorama can help transform your existing on-premises cameras into computer vision-enabled devices, so that you can monitor all of these processes, remove bottlenecks, and make improvements to the overall supply chain. So with services such as Lookout for Equipment, Monitron, Lookout for Vision, and Panorama, you can use machine learning to add end-to-end monitoring and analysis to your industrial processes. Whether you're manufacturing cars, mobile phones, producing and packing food, collecting harvests, generating power, or yes, even building billions of pencils.
The world's top pencil producer is Faber-Castell out of Cleveland, Ohio. It produces more than 2.3 billion wood case pencils every year. That's your fun fact of the day. You can thank me during your next trivia night. Now let's shift from pencils to a deeper dive on industrial ML and some of the services Dr. Wood was just telling us about. Reporter Rob Munoz caught up with Mike Miller, who is the Director of Artificial Intelligence Devices at AWS.
Well, Mike, thanks for taking the time to walk me through these launches here. AWS Panorama Appliance has been getting a lot of attention. What is it?
Yeah, hey Rob, thanks for having me here. So the AWS Panorama appliance uses computer vision to improve industrial operations, especially for use cases that once might have previously relied on human visual inspection, kind of like inspecting products for quality problems as they come off a manufacturing line, or even monitoring vehicles entering a truck yard. The appliance specifically allows you to deploy computer vision applications for industrial processes to locations at the edge, which is important in a certain set of situations. So sometimes the computer vision that you want to run has to be very low latency. You need predictions to come back very fast. So you can't afford a round trip to the cloud. Sometimes there's not great internet bandwidth in these industrial locations. You can't stream high bandwidth video to the cloud in these cases. So you need to run those machine learning models on the edge. And finally, in some use cases, the customers have data privacy or governance requirements where they can't take the video from their sites and send it off to the cloud for processing. So in these cases, you need to use the AWS Panorama appliance, which I have here. You need to install one of these things on site, and you can deploy machine learning models and applications onto this device to execute these computer vision predictions at the locations where it's needed.
I know we want to learn more about that, but how does it actually work?
Yeah, so good question. So this is the device again. So the device installs on the network with existing cameras. So it's designed to work in tandem with cameras, existing IP cameras that a customer might have on their network. So you can see there's a couple Ethernet ports on the back here for redundancy or to connect to different subnets. Once this device powers on and is registered, it will automatically go out and discover camera video feeds that are on your premise. Then machine learning applications are deployed to this device from the cloud. It's got a very powerful GPU processor in here, so it can actually process multiple camera streams coming into it at the same time, running multiple machine learning models on those camera streams right here on the box without needing any video or other data kind of going up to the cloud.
Wow. Mike, you're also responsible for a lot of the AI devices that AWS has. Can you also tell us a bit about some of the new devices developed for industrial machine learning applications?
Yeah, absolutely. So you probably just heard about Monitron, which is an end-to-end machine monitoring system that uses machine learning to enable predictive maintenance. It's made up of sensors, a gateway, and an ML service to detect anomalies and predict when industrial equipment will require maintenance. So I have a couple examples here. This is one of the sensors. So this sensor can detect temperature and vibration. You mount it to any kind of rotating machinery, so pumps, fans, conveyor belts, motors, and it relays its data over Bluetooth to this device here, which is the gateway. So the gateway will connect via Wi-Fi to the internet, collect all the data from these sensors, and send it to the machine learning service in the cloud. That machine learning service will use a machine learning model and the sensor data that it's provided to determine kind of anomalous patterns and then send an alert through a mobile app. So you can have a field technician or a machine operator who knows nothing about machine learning, who even knows nothing about the cloud, just use this mobile app receive an alert and go to that equipment to determine if it's needing any maintenance or if there's a problem with it. So it really kind of makes predictive maintenance something that any customer can take advantage of without any level of machine learning or cloud expertise.
Mike, I appreciate you taking all the time that you did to walk us through all of that, and very informative. Rudy, back to you.
In this year's machine learning keynote, an exciting new ML service called Amazon Health Lake was announced. Amazon Health Lake will be used by healthcare and life sciences customers to better innovate on behalf of their patients. To talk about this new service, I'm joined by Taha Kasut, Director of Machine Learning. Welcome, Taha.
Thank you for having me.
I want to get right into a big announcement we heard earlier. Let's talk about Amazon Health Lake. What is it and what inspired the team to go ahead and build it?
Absolutely. I'm super psyched about Amazon Health Lake's announcement. It's a HIPAA-eligible service for healthcare and life sciences organizations that aggregates an organization's complete data across various silos and disparate formats into a centralized AWS data lake and automatically normalizes this information using machine learning. This is of tremendous value to these customers that are hiring the service to make sense of all their data. The machine learning powered data lake service identifies each piece of clinical information. It then tags and indexes events in a timeline view for every patient with standardized labels so that way it can be easily searched. And then structures all this information into the fast healthcare interoperability resources, or FHIR, FHIR. It's an industry standard specification in order to have a complete view of the health of individual patients and entire populations they serve. Now that all the information is normalized and structured, these customers can easily query, perform analytics, and run machine learning to derive meaningful value from all their information. These organizations want to make more precise predictions about the progression of disease, efficacy of clinical trials, and accuracy of insurance premiums, among many other applications, while they are hiring the Amazon Health Lake service.
And how has the customer feedback been so far on this new service?
It's been great as it touches on addressing a very heavy lift for most of these customers. Over the past decade, we've witnessed digital transformations in healthcare, primarily with the adoption of electronic medical record in digital format, where these organizations are capturing huge volumes of patient information from family history and clinical observations to diagnosis and medications or testing procedures on a daily basis. But this data is often unstructured, with information trapped in lab reports, insurance claims, clinical studies, recorded conversations, as well as medical images like x-rays and CT scans and doctor notes and more. So every healthcare provider, payer, or life science company is trying to solve this problem on their own in structuring this data. Because if you do, you can now make better patient support decisions, as well as design better clinical trials and operate more efficiently and identify population health trends. However, the process to extract this information is very labor-intensive, time-consuming, which can take specialized teams weeks and months, and is often error-prone. And as a result, the cost and operation complexity of doing all this work well is prohibitive to most of these organizations, where the majority of them just end up missing out on the untapped potential to use their complete data to improve the health of patients and communities. Again, all this information aggregated in emerging FHIR standards is only a start towards the goal of standardizing structured data, but the unstructured data still needs to be tagged, indexed, and structured in chronological order to make all this data understandable and be able to query. So with Amazon Health Lake, we are demystifying these challenges for our customers in the healthcare and life sciences domain, where we want to remove this heavy lifting for them by organizing and normalizing all this information so they can take full advantage of it without the custom work needed on their end.
Can you tell us how doctors and patients both benefit from this service, or how they will benefit from it?
On one end is, if you look at today at the most widely used clinical models to predict someone's risk of disease, they oftentimes include very few data points, upwards of 20, maybe 30 data points, like someone's risk of heart attack or heart failure. However, if you look at an individual's medical record, there might be at least 300,000 data points. The majority of this, unfortunately, is untapped information stored in medical notes. None of this information is used today to manage patients or predict outcomes. And what you want all this information to come together at the point of care and then to look at this complexity compared to the rest of the population. With Amazon Health Lake, you can now have a complete view of an individual patient, so you can make predictions much earlier than you could have previously, or intervene quickly to improve care and reduce cost. Healthcare organizations are telling us that they can manage their entire population now with advanced analytic and personalized models, not limited by subset of data or a subpopulation, especially in light of the growth of downside risk-bearing contracts and more value-based care adoption. The other important benefit from the Amazon Health Lake provides is now you have access to all this normalized data through its standard-based APIs. Allowing you, with patient consent, of course, is to share the data between health systems with popular third-party applications or analytic platforms. Providers can also collaborate more effectively to provide continuity of care and reduce any unnecessary gaps in that care. Patients can have unfettered access to all their medical information, which can lead to better patient engagement, better patient experience, and even better health outcomes.
Well, thanks for joining us, Taha.
Thank you very much. I really appreciate the opportunity.
That was Taha Kasut. He's a director of machine learning at AWS. Tomorrow on the show, we make a pit stop into the world of Deep Racer and find out all about this box of doom that everyone is talking about. Plus, exclusive thoughts from AWS CEO Andy Jassy that you won't find anywhere else but on the AWS News Desk. That's all for today. Thanks for watching. I'm Rudy Chetty, AWS News Desk, signing out.